Hello and welcome to Labs and Latte, a show where we dive into the Enery Labs curriculum while sipping on our favorite bean-based beverage. And I have another latte here today. I kept it simple because we're sort of dealing with a global pandemic right now, so I'm not trying to reinvent any wheels. But I'm sort of practicing my latte art and getting better at the craft. You know what's funny? Latte art is actually, I don't want to call it difficult because it ends up being a pretty simple exercise once you understand the fundamentals of frothing milk and various other things. But man, it took me a long time to get to that point. It's kind of like anything else. Simple is actually kind of hard to achieve. And yeah, no, I'm obviously I'm no artist, but it is nice now that I can consistently at least build like a little tulip or something simple like that. It took a long time to get to that point though, because there's a whole bunch of things that have to be right about the way you froth the milk and all kinds of different things like that. Otherwise, it just doesn't work. But yeah, a little quick note, we are dealing with a coronavirus pandemic right now, so I'm taking the opportunity to get out some additional Git content, and today we're going to be looking at part 3 of the Git series that we've been dealing with thus far. In fact, today, as well as of yesterday, we published the stage or the chapter after this one. So I will actually be recording this video as well as the next video right now. And so if you're watching this and wondering where the next part is, that'll be out in about a week once I get it all edited. So yeah, part 3, we're going to be talking about parallelizing your work with Git branches. Now, if you followed along thus far, and again, the links are in the description for the actual lessons, and I do encourage that you play along. What we've done thus far is we've sort of played around with our own sort of domain of things. Like in the first part, we just set up Git really in our first repository, and in the second one, we made our first commit and talked about how commits work and how you can do like git add and staging and how all that works. What we're going to be doing now is sort of going beyond that into the realm of a little bit of multitasking. Now, this multitasking may just be multitasking yourself. So like if you're working on two different sort of aspects of your Git repository, whether it's, maybe you're storing network configurations and you have 50 devices in that repository, their configurations rather, in that repository. Maybe you don't need to work on them sequentially. You can work on them independently if those changes don't impact each other. And you can use branches to effectively isolate that work so that you can sort of work on those things independently while still maintaining the advantage of using Git for version control all along the way. And then what you can do is you can reconverge that work once they're done. And that's sort of one of the canonical use cases of Git branching. Is basically like I have a piece of work that I want to do, and master the master branch is kind of the idea of this is sort of like the golden copy of the repo. It's sort of it has a special status when you look at most repos. Some repos use a different branch for their sort of their main branch, but most Git repos use master as their like main branch. And the idea is there that what's in master is sort of quote stable, or at least it's more stable than some of the other branches. And so what you do is you do the work in those branches, and then when you're done with that work gets merged back in. Sometimes it doesn't. Sometimes there are plenty of use cases where those branches don't get merged back in. So we're going to be talking about all of this and more in this lesson. The first thing that we want to do is we want to get back into our repository. So we'll go into cd my first repo, or rather we'll cd into my first repo. Git status just to see where we're at. You can see we're on the master branch. As I mentioned, the master branch is basically what we've been working on thus far. It is the main branch. If you do nothing with branches, you're going to be working on the master branch. And as you can see, our working tree is clean, so we have no files that we haven't committed yet, or untracked files. All of that stuff is pretty vanilla. Now, if we scroll down in the lesson guide, you can see a little bit of a backstory that was written to sort of give an example. So I'll sort of retell that story a little bit. The idea here is we're using Git to manage a change to a network configuration. And so in this example, we've opened a ticket with our change review board. Our change review board is very friendly with Git. Because we live in a magical universe where that's true. I'm being a little bit facetious. I'm sure that the times have changed in recent years, but when I was doing this, change review boards were not Git savvy. And we've been assigned a change ID of 123. We've already started using Git to track changes to our configurations. And so what we're going to do is we're going to use this change ID for tracking purposes, just to keep everything sort of obvious. And so what we'll do is we'll create a branch, and on that branch we will do our work. And effectively, that work will represent in Git. We'll actually make commits on that branch, and that's what we'll tell the change review board that we want to commit, and merge back to master eventually once it's approved. And what we can do is run git checkout, and we'll do the -b flag. It's a sort of a shorthand. There's, as I mentioned, I think in the last video, there are many commands in Git that are actually aliases for other commands. This is sort of shorthand, a very common shorthand for, hey, I would like to create a new branch, and I would also like to check it out because I'm going to go do stuff on it. And that's what git checkout -b does. We'll name the branch change-123 again because that's sort of the ID that, and this is obviously something you can name on your own, but we'll name it this just because it's the ID that we were given from our change review board, and so it just keeps things nice and simple. So as I sort of teed off there, the git checkout command, we've used that before. We use that to do things like sort of revert a change back to what was already previously committed. And in this case, what we're doing is we're saying, look, I want head to point to this new branch that I'm creating simultaneously with the -b flag. And so that's what's taking place there. Okay, so for change-123, let's say we want to change the IP address of EM3 from 10.31.0.11 to 10.31.0.12. Now, in the lesson guide, you'll see that I used basically, I call it sed foo. It's just using the sed command to replace text within the text file. And the main reason for that is so that it could be a one-liner. Just so you can click run this snippet if you don't want to open a text editor. Not everybody's comfortable with a text editor, so that's the option that I give. I, however, am comfortable with a text editor like VI, and I am going to open it. So interface config, and you can see EM3 is currently set to 31.0.11, and per the lesson guide, we'll change that to 12, I think is what it says, right? Yeah, .12. Save. And we will then run git status. You can see the change is now not staged, but is recognized by Git. We'll see Git Diff to see the actual change. Looks like it's there. That's good. Okay, so let's commit this. So git add interface config. This moves, just to review, this was covered in the last section. Git add interface-config.txt moves this change that we've recognized here into staging. And by doing that, we can then run git commit. And we'll do -m changed IP address of EM3. There we go. We've got our commit ID. We've got a little summary where we've deleted one row, deleted one line and inserted one line. And we can also run git show to see the most recent commit. We can see that the diff is exactly what we saw prior to making the commit. So everything looks great. Now, this is where things get a little weird. As I mentioned, Git is a distributed version control system, and so you have to think about things that are happening outside of the thing that you're immediately working on. Like we're working on the branch. I lost the branch name. Change-123. Sorry, it's been a long day. We're working on this branch, but we're not the only ones working on this repository. Especially in the world of, which we haven't really gotten to this yet, but especially in the world of GitHub, where a copy of a Git repository is actually held in the internet, and people are sort of pushing and pulling from it all the time. You sort of have to operate under this mentality that things are happening outside of the thing you're working on, and you need to be prepared to sort of integrate those kind of changes into that environment. And in this lesson, what I've done is I built a script that simulates this taking place. And so imagine there's this coworker of yours named Fred. We're gonna know some things about Fred in this by the end of this video. He's working on his own change ticket. We'll call it number 124. And what that does is it changes the IP address of EM4. Remember, we changed EM3. So he's changing the IP address of EM4, and he's using the branch change124 to do it. So let's say the change review board for some reason likes Fred more than us, and so his change gets approved before ours. Obviously, there were some under the table dealings going on. Money changed hands. We're not going to ask questions, but that's what happened. Now, like I said, what I did was I wrote a script to basically simulate this taking place. And of course, if you feel like you want to take a peek at this script and see how I did it, please feel free. It's not really the point of this lesson, so I'll sort of just run it, and we'll for now trust that it did what we think it will do. So what happened in this script is Fred effectively had his own branch merged into master. So if you visualize this, basically we branched off of master. Ostensibly, Fred did too when he created change 124, but unlike us, unlike change 123, his branch has merged back into master, and so now all of his commits are in master. And so what this means is we actually have in our branch, we are simultaneously behind and in front of the current master branch, because we have a commit that we've made on our branch that master does not have, and the vice versa is also true. They have commits. Master branch has commits because of Fred's branch that we don't have, and so now we have this mismatch. And what we want to do is we want to catch our branch up effectively. We want to tell our branch, hey, there are commits on the master branch that you don't have. Bring them in. Now, this is usually okay because, again, our branch is still considered sort of a work in progress. We haven't merged it back into master, and so pulling commits into our branch is fine. It's that final merge of our commits back into master that needs to be approved. This is actually fairly common in the world of software development, in things like pull request reviews and things like that, where you can do whatever you want in your branch, but before you pull it back into master, and then, by the way, that's where the term pull request comes from. I'm requesting that people pull my code into their repository and in their master branch. So basically, that act of merging back into master is sort of that last step. It needs to be sort of vetted either through tests or through code reviews, or preferably both. And the same is true in this environment where we are having a change review board approve the changes that we're making. Hopefully that wasn't too confusing. Now, the cool thing is we ran the diff command in the last exercise. I'm going to actually sip my coffee because I haven't yet, and I'm starting to need it. Oh, man. I'm kind of too good at this. Random self high five. Wah! So git diff, master change 123. So git diff is a command that we ran in the last video to compare the difference between the current version of a file and the version that we had previously committed. But Git Diff can actually receive a lot of different arguments, and in this case, what we're doing is we're actually comparing entire branches. And so if we run this this command here, Git Diff Master change 123, what we're doing is we're saying, give me all of the differences between these two branches, right? Commits aside, just take all of the differences in all the commits, however many there are, and aggregate them together for me and show me just the full diff between the two branches as a whole. And as you can see, our change is still there because obviously that's the commit that we've made that master doesn't have. But the change to EM4, which Fred made and made some under the table business dealings to get his change merged, is also in there. And so that's what I mean when I say we have a commit that master doesn't have, and then also vice versa. So we can't do anything about our change because, again, we don't want to merge that yet. It's not approved. But we can bring our Fred's commit, rather, into our branch fairly simply. Now, the way we do that is we say git merge master, and this should be it because we actually checked out change 123 already. And let's just verify that just to be sure. Git status. Yep, we're already on this change. So we say git merge master. Now you'll notice I have some other flags here and arguments. Again, most of this is just to make it a one-liner. What this will do is it'll open a text editor for us. You'll find, I think I mentioned this in the last video, you'll find that by providing the -m flag, you can sort of override Git's need to open a text editor because you're providing the text that it's asking for basically in line. That works for a lot of commands. Git commit is one of them. Git merge is another. It's going to ask you for effectively a commit message because that's what it's doing. When you're doing a merge, what you're doing is you're creating something called a merge commit, and so you are making a commit, and that's why it needs a commit message. So we'll leave all of that out, and we'll get prompted because again, we're not afraid of the text editor here. Git merge master, and you can see it already has a commit message for us, which we find is fine. You'll notice I accidentally, I guess by default in this environment anyway, Git uses nano, which if you use nano, that's fine, whatever. I prefer VI if I'm using a graphical or a sort of a terminal editor, but they both work perfectly fine, so I'm not here to start a flame war. We will do Control X to save, and you can see that makes the merge commit. Cool. And then finally, let's do another diff on the branches. I'll just do up a few times, and you can see now the diff only shows the change that we've made. So again, we haven't merged our branch into master, but we have merged master into our branch. If that makes sense, the commits that master had that we didn't, that situation has now been resolved. So we now have all of the commits that master has, but we still have one more commit at the moment that master doesn't have, and that's what's being shown here. Cool. Oh, Fred, he's at it again. What is he up to this time? So right now, he's not only making more changes, but he's actually making a change to your part of the configuration. So before, and this is one of the cool things about Git, even if you're working on the same file, and this is why I mentioned in the last video, Git is actually very sensitive to changes to files. Not just, it doesn't work on just a file basis, it works on changes to files. And so if you're making if two people are making changes to the same file, as long as it's effectively two different parts of the file, Git's actually intelligent enough to be able to just resolve that just fine. It doesn't really matter because it only works on sort of those localized changes. And so even though Fred made a change to the same file, it was to a different interface, and therefore both of those changes could get merged just fine. In this case, however, excuse me, in this case, however, Fred is making a change to EM3. We don't know why Fred does what he does. He's clearly a malicious insider threat that we need to get rid of, but in the meantime, let's just deal with him in the world of Git. Again, I wrote a script to simulate this. If you want to take a peek at what is going on in the script, feel free, but it's basically a simulation of what I just described. Fred is making changes to the file into the same interface line that we've been making changes to, and committing them and then merging them because, again, he's paying the change review board. It's an imaginary scenario. Don't hate on it too much. Okay. So we, of course, are busy working on our own change. So just like before, what we do is we see that there are new commits on the master branch that we don't have, and so we play catch up once more. Just like we did 5 seconds ago, we'll do Git Merge, and again, we'll just make sure we're right on the same branch. Change 1, 2, 3, excellent. So we'll do Git Merge Master change 1, 2, 3. Actually, you don't need to have that second branch in there. Again, you just, as long as you have Git. As long as you have the 1, 2, 3 branch checked out, then you can just run Git Merge Master. Okay, and you can see it's not even prompting us with the commit message because it actually ran into a conflict, and this is where we run into something that is probably one of the scarier terms in the world of Git, and that is called a merge conflict. It sounds scary because it has the word conflict in it, and conflict is a scary word, but it actually isn't that big of a deal once you understand what's happening. And there are a bunch of different kinds of merge conflicts. We're only going to deal with one kind today, but effectively what's happened is that Git is, as I mentioned before, Git is usually very intelligent, and it can manage sort of changes to the same file as long as they're separate, but if they start to overlap, that's one of the things that causes a merge conflict. And as you can see in the text, it just says, hey, we have a merge conflict in the text file, interface-config.txt. Now, if you scroll down on the lesson guide, you can see a snippet of what Git does to a file to indicate a merge conflict. What it'll do is it'll actually insert these sort of markers into the body of a file. And these are pretty well recognized. People sort of know, people that are familiar with Git know to look for these. In fact, some CI pipelines actually check for these because it's not uncommon to find these actually in code or other text files because people, when they resolve merge conflicts, which we're about to do, they forget to take these out. And so these are pretty recognizable patterns. The idea here is basically this is what the change that we saw in the head right now, which is the branch that we've checked out, and here's the change that took place on master, right? Master branch. And so it's basically telling us, hey, I don't know how to resolve this. Basically the two changes tried to change the same line, and I don't know which one I should pick. So what I'm going to do, and I'm personifying Git now, so try to keep up with my clearly sane ideas. Basically, I don't know how to resolve this situation. You made the same change, or you made two different changes to the same line, but I want to, I don't know how to resolve this. So that's understandable because Git is not a decision maker. It's just telling us that it has a conflict. So it inserts this whole block of text into the lesson, or into the configuration file, and it's basically waiting on us to resolve this. How do we resolve it, Matt? Good question. Let us go into the file. So again, vi interface config. If you want to use nano, it's totally fine. If you want to use something else, also totally fine. And you can see, yep, there we go, right in the text file. You can see that it has those three new markers, and you can see the address line is repeated because, again, it doesn't know which one that we want to pick. Now, the really cool thing about using a text editor that's not in the browser, like if that's not in the terminal here, Like if you're using VS Code, for instance, and I resolve merge conflicts in VS Code all the time. A lot of those modern text editors will give you sort of pointers to help you resolve this. And VI does the same thing too, by the way. You just need plugins for it that I don't have in this environment. But they can kind of tell you and give you little markers that you can maybe click with a button and it does this for you. But we'll do it manually for now because it's not a big deal. The change here is address 123.123.123.123. That's Fred's change, and we don't want that. We know better because this is our interface and EM4 is his interface. And so basically what we want to do is overwrite his change with our own. And the way that we do that is by simply taking out that section. Don't forget the markers. It's very important. Address 123.123.123.123, and then all of the markers, just take it out. And don't forget the top marker, even though that's pointing to the change that we want. This is not valid Junos configuration, and so we don't want it in there either. So we then save the file, and then as I mentioned in the lesson guide, if you scroll down, and again, this is the one-liner to do what we just did. If you want to use that instead, feel free. But like I said, I want to use the text editor. Let's do git status to see where we're at. Now, as you see in the output, this hasn't actually resolved the merge conflict. Really, all we've done is we've just edited a text file. We haven't told Git about what we've done. Git's not automatically watching for the changes and then taking action accordingly. It needs us to tell it that we've resolved it, basically. And so what it's doing here is it's saying, it's actually giving us some instructions. Fix the conflicts and then run git commit. So let's do that. So let's do git add interface config. And you can see all conflicts fixed, but you are still merging. Again, haven't made the commit yet, so let's do that. And again, if you look at the snippet here, you can see that I'm providing the message inline, but we'll just do it in a text editor. Merge branch master into change 123. Let's actually change that because I do like the message that I had in the snippet. Resolve merge conflict overwrite Fred's change. And I don't need quotes because I'm in the editor. Okay, there we go. Okay, so yeah, let's do git log one line just to see where we're at. Cool. So change 124, if you'll remember, that was Fred's original change that didn't cause any conflicts. That was his original change. That's still existing. We haven't deleted that branch, or Fred hasn't deleted that branch. You can see we also changed the IP address of EM3. We also caught our branch up with the latest commits from master. You can see Fred's change is still on master, where it says, I'm Fred, and I'm conflicting with your change, which is the commit that changed EM3, by the way, that did the 123.123.123.123. And then finally, head is still pointed at change 123, which the latest commit there is resolve merge conflict overwrite Fred's change, which is the one that we just ran, A58. A58. So yeah, that's basically what took place over the last couple minutes. Now, the last thing that we do, and again, this is going to vary based on the platform. As I mentioned, if you're like in GitHub or something like that, which we'll get to in a future section, there are actually buttons you can click to do what we're about to do. But the good news is we also have the ability to just simply merge the branch here locally. And this is probably something that like a change review board would do. Again, maybe not via the command line, maybe via something like a web UI. It's not uncommon to do it that way. But at the end of the day, web UI or not, it still boils back to what we're about to do on the command line. So if we do git checkout master, you can see we're on the master branch. Now we'll do a git merge. Change 123. Again, remember the last syntax. We had change 123 checked out, and we said git merge master. What that meant was, hey, give me the commits that are in master and bring them into my branch. Now we're doing the reverse. Now we're saying, hey, change 123 is approved. The change review board loves it. They're approving that we bring those commits into the master branch, and so we're going to merge those commits here. So we've checked out master branch, and we are now merging change 123 into it. Excellent. All done, except our branch still exists. Now, there's a couple ways you can do this. I like to use the lowercase d flag for git branch. I don't think I mentioned this in the lesson guide, but you can also do the uppercase d. The difference here is that if you run git branch d and then say change 123, what it'll do is it'll actually check the commits in that branch, and if any aren't already on master, meaning it's not fully merged, it will actually reject that. So it's a nice way to protect against undesired deletions. If you accidentally deleted a branch that has work that you didn't merge, it's a nice protection against that. Of course, you can override that with the uppercase D, which is not uncommon if you want to just get rid of like a release branch or something like that that's very old. there are various reasons why you might want to do that. But I would say stick with the lowercase d because it does protect you against accidentally deleting a branch that you didn't want to delete. Okay, and yeah, we'll run that. Yeah, deleted branch change 123. Okay, so yeah, this was again whirlwind tour, as many of these are into Git branching. I hope it was enjoyable. I hope you learned something. Please feel free to check out NRE Labs. If you go to nrelabs.io, we've got a lot of lessons, not just this one. If you want to go to this particular lesson and follow along, again, the link's in the description, and I encourage you to do that. Until next time, keep drinking coffee and stay safe out there with the coronavirus. Seriously, it's kind of scary these days, but you know what? We're going to get through this as long as we all stay home. So be safe. Thank your local medical professionals in your local community and your families, and yeah, stay safe out there.